Good to see you again. In this video, we'll look at another real exam problem. This one is a classic algebra question. By the end of this video, you'll learn a method you can reuse on any similar problems. Feel free to pause here. Now let's interpret the question together. Circular motion. There are actually two equations for circular motion. One is the centripetal force equals to mv squared over r. M is the mass, v is the linear velocity, r is the radius of the circular path. This is another equation for circular motion. Centripetal force equals to m omega squared times r. Omega is the angle of velocity here. And this is another piece of information I would like to highlight. And this one as well. It might sound awkward to you at first, but actually it means angular velocity. And the first one is the initial angular velocity, and the second one is the final angular velocity. The initial angular velocity is theta over t, and the final angular velocity is 2 theta over t. Take a moment to think about this. What does it tell us about the relationship between the initial and the final angular velocity? Okay, it's telling us that the final angular velocity is actually 2 times the initial angular velocity. Then let's continue. I want to label this piece of information, string tension is kept constant. This is the string and the tension is going this way, and this force is actually providing the centripetal force. Some student may argue that, because this mass is moving in the circular path, so it should experience a force this way. No, this is not right. Whenever you see an object moving in a circular path, the resultant force acting on it is always to the center of the circle. And let's interpret the meaning of string tension is kept constant. Since we know that a tension is providing the centripetal force, tension and centripetal force should be same. That means centripetal force is also constant. Now let's build the logic chain together. I'll first write down the equation. I am picking this one instead of the other one because obviously the question is giving us information about initial and final angular velocity. And then I need to do rearrangement to make r the subject, because essentially we are comparing the initial r with the final r, r1 and r2. And lastly, we can plug what we have interpreted from the question into this equation. If you'd like, pause here and then try the algebra on your own, then press play for the full solution. Okay, let's solve it step by step. First, I'll write the expression for R1. It's Fc over m omega initial square. Then I'll write the expression for R2. For R1 and R2, both of them share the same centrifugal force and the same mass, but their angular velocity are different. And remember from our interpretation, we get the final angular velocity is 2 times the initial angular velocity. And we can plug it into here. And we get this. And we can further simplify it. And we get this. And we can compare this expression with this expression. And you can tell that they are the same. So we can replace this expression with R1. And this gives us the final result. R2 equals to 1/4 of R1. Let's summarize. In this video, we talked about how to solve algebra problems. Algebra problems always involved 2 scenarios: before and after. To solve the problems, you need to first get the right equations, and then rearrange to make what we are looking for the subject. Next, write the equations for two scenarios, R1 and R2, and plug in the ratios that we get from the question interpretation. Last, make simplification and compare the two expressions. If the steps still feel clumsy, bookmark this video and rewatch it tomorrow. Repetition locks the method in.